Let's do another Leetcode session. Play some piano music. All right. Well, this one has 747 likes only and 1,925 dislikes. So we'll see how this one goes. We're at the rating 1396 now, almost breaking 1400. So we'll see if we can get to that soon. So we have number 788 rotated digits. An integer x is a good. An integer x is a good if after rotating each digit individually by 180 degrees, we get a valid number that is different from x. Each digit must be rotated. We cannot choose to leave it alone. A number is valid if each digit remains a digit after rotation. For example, 0, 1, 8 rotate to themselves. 2 and 5 rotate to each other. In this case, they are rotated in different directions. In other words, 2 or 5 gets mirrored. 6 and 9 rotate to each other, and the rest of the numbers do not rotate to any other number and become invalid. Given an integer n, return the number of good integers in the range 1 to n. I don't understand this. I don't know what rotating individually by 180 degrees. What does that mean? Each digit must be rotated. A number is valid if each digit remains a digit after the rotation. After rotation. For example, 0, 1, and 8 rotate to themselves. Why do they rotate to themselves? What does that mean? 2 and 5 rotate to each other. 6 and 9 rotate to each other. The rest of the numbers do not rotate. How is that 180 degrees? 180 degrees. Oh, is it talking about 180 in terms of the image of the number? Okay, so 6 and 9 rotate to each other. 2 and 5, I guess, rotate to each other. I guess it's just arbitrary at some point. 0, 1, and 8 rotate to themselves. The rest of the numbers do not rotate and become valid, okay? So, an example, n is equal to 10. Output is equal to, let me change that. New version. Change to new version. Hope the music's not too loud. Okay, so on this timer, we have 4 good numbers in the range 1 through 10, 1 to n, 2, 5, 6, 9. Note that 1 and 10 are not good numbers since they remain unchanged after rotating. 1 to 10 to the 4th. Okay. Each digit must be rotated. One and 10 are not good numbers. So they're good if after rotating, we get a valid number that is different. What about like 13? Alright, so no, what about like 88? That wouldn't be a good number either way. How about like 69? That would turn into 96, and that would be a good number. So do I go to each digit? In the number? And does each digit must rotate? I just feel like I need to test different cases, because I don't understand if there's multiple digits. They don't give an example other than this 10. I guess you have to do something with multiple digits. So one of my questions is, what if you have a number like 697? 7 does not rotate and becomes invalid. So what happens to that? So let me try like 13. Or like 63. Or like 23. Let's try 23. Let's see. Return. And we're supposed to return 9. Let's run. I guess, I don't know. That probably wouldn't give me a 23. About like 12. Try that. 12. So if we do 12, we have 10, and 10 is 4. So 12 should be still 4, if I'm thinking correctly. So let's try it. Five. Okay, no, so never mind. Well, I guess what my question is, so 14. So 11 wasn't good. 12 is good. 13. Let's see, 13. Shouldn't be good. It should not be good. 14 should not be good. 15 should not be good. Or 15 should be good. 16 should be good. 17. So 15 and 16 would be 7. 17 is not good. 18 is not good. 19 is good. 20 should be 8. So at 20 we should have 8, I'm pretty sure. But it'll probably be more. No. 20 is 9. I missed one. Okay, so 21 should be good. 22. So 21 should be good. So that would be 10. 22 should be good. That's 11. And so 23, it should be 12 and 23. I forget what I got. So 23 should be 12. If it's 11, that means that 23 is also good, even though 3 is not a good number. So it doesn't have to be with, or a valid number. It doesn't have to be with a valid number. So as long as there's one digit that can rotate, it's a good number. As long as there's one digit that can rotate and change, it's a good number. I think 8. So let's see 8. Yeah, like 8 doesn't count in there. 1 doesn't count. 0 doesn't count. But it's from 1 to n anyway for that one. So, okay. So I think I got what's good and what's not. And we have 10 to the 4 numbers. And so, interesting. Okay, we have 10 to the 4 numbers. So we can loop through all the numbers, right? 10 to the 4. We can just loop through all the numbers. So then if we loop through all the numbers, the thing is, once we get to multiple digits, now we're trying to check if there's like a 6, 9, 2, or 5 in the number. Six, 9, 2, or 5 in the number. And that's where, if there was 10 to the 4 numbers, and we had to check 10 to the 4 digits, then that would be a problem. So how do we get away with checking every digit? Is there a way we can do that? Not have to check every digit. Is there a way we just don't check everything? How do we know a digit is there? For example, if we have like all ones and then a 2 at the end, or 2 in the middle. That would be a good number. How are we finding that 2? Maybe as you're counting, right? So you go through each number. And as you're counting up, anytime you add a new digit, storing that digit until it changes. And then every time we add a new digit, storing that digit. Actually, I don't know. Let's see. Would all numbers in 20 be a good number? So let's see. So at 20, we have 9. And at 30, we should have 18. Or like, let's do 29, we should have 18. So they're not counting 29, they're not counting 28. So I guess they count 21, 22, 21, 22, 25, 26, and 29. So it has to be... Yeah, so it can't be with an invalid number. So if there's one invalid number, then it doesn't work. Hey, what's up, Leetcode? I did 8 problems this week already. So I'm doing pretty good. And now I'm doing this one, and a lot of people don't like this problem. Yes, 8 problems. Yep. By the way, guys, is my voice clear? Okay, good. Yeah, so I'm trying to solve this problem, and what I get from it is that if a number has 2, 5, 6, or 9 as one of their digits, then it counts as a good number. If it's multiple digits and it has one of these numbers along with 0, 1, and 8, then it's also a good number. But if in a multiple digit number it has some of the invalid choices like 7, 3, for example, then it becomes not a good number. And so I have to find all of the good numbers. There's 10 to the 4 maximum numbers. So if I can find a way, so I can loop through all the numbers, but I don't know if I can, like, I'm not gonna be able to loop through all the digits to check, you know, their validity. So I gotta figure out if there's a way I can do that. So let's see. But yeah, so like 20 would be a good number. 21 would be a good number. 22 would be a good number. 23 is a bad number. 24 is a bad number. 25 is a good number. 26 is a bad number. 28 is a good number, I think. And 29 is a good number. Yeah. So, oh, and 27 is a bad number. 7 is bad. 28. I didn't solve 1400 problems. I'm at rating 1400 on this list, but I started probably somewhere in the 1300s, 1350s, something like that. So no, I haven't done that many problems. Why do I have Smart Quarter 5? Because that's how I get in the alert. If you put that in your tag when you're streaming, you alert to the Discord if you're in there. Okay, so these numbers are rotated. Are good numbers, sorry, good numbers. Check is good. Now, how do I, it's easy to check if a single digit is a good number. How do I check if a number like 20 8 is a good number. Because 88 is not a good number, but 28 is a good number. So I need to locate this 2. Maybe it doesn't matter. Maybe I can just check every digit. Or maybe not. Because I have to check every number, too. I have to check every number and every digit. Maybe when I get to... Okay, so let's say I get to 10, right? Now maybe we have this. Oh, we could say 1 is good, so let's just focus on this one now. And then if we have this, we say, oh yeah, 10 was good. We stored it somewhere. Now let's just focus on this one now. If we can do that. Then we would have to keep track of all the good numbers. What is the problem with checking every digit and every number and every digit? I thought that it would be too much. Maybe I'm thinking wrong. But there's 10 to the 4 numbers. And wouldn't you go through... So like if you're just going through 1 through 10, it's just checking every number. Or 1 through 9 is checking every number. But then once you start to get like 22 or 23, don't I have to check every specific digit? And then once I get to like 10 to the once I get to like 10,000, now I have to check 5 slots for that many. I guess that's not bad, right? There are 10 to the 4 numbers, each have at most 4 digits. Ah, okay. Yeah. So I could just do that. Okay, so just thinking of it wrong. So I just get to check every digit. Loop through the numbers and check every digit in the number. And so I guess for for x in 1 range, 1, 2, n plus 1. And then I gotta check if okay, so I gotta separate the digits, and for each one I gotta do my check. So while x is greater than 0, I have to check the digits, right? So we go if x mod 10 or x mod 10 So, okay, so I have to check if there's a 6 or a 9, 2 or 5 in any of the digits. And then I have to check if the rest of the digits are not valid or not invalid. So if it's invalid, maybe I can do this in a separate function. Make it a little bit easier. Let's just do. Check good and for each digit, let's do. So I could probably put these numbers maybe in the set 2, 5, 6, 9, and then check if it's in the set. Or I could just maybe do. I don't know. Would it be like this? 2, 5, 6, 9. So if it's in 2, 5, 6, 9, then so okay, so let's do this. Result is equal to false if any of the digits are 2, 5, 6, 9, then result is equal to true. Else, or elif x mod 10 in 3, 7, 3, 4, and 7. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So yeah, if it's in 3, 4, 7, then return false because it's invalid now. And then at the end, you return res. So this is saying if a digit, if there's a good digit, then make it true. Else, if that digit is bad, we're just going to return false. And then if it's any other of these numbers, which are 0, 1, and 8, it's just going to ignore that and go to the next. Oh, but we got to do x equal to 10 until we get to 0. And then we return. So let's try is check good. Let's try it. 23 prints. Check good. Return 0. Variable x reference before false. 22 true. 28 true. 21 true. 24 false. Okay, we're good. So I think that's good. And then so now for x in range 1 to 10 1. And so it turns true or false, but we need to, maybe I just return 1 or 0. And then I can do, let's do this. Return 0 is false. 1 is true. 0 is false. Return yes. And then I could do check good. X. And so now if it's good, it'll return 1, and we can just sum up all the ones, and we can return that number. Try that. Okay. Let's try 2, 0, 6, 7. Is that a valid number? No. Yeah. Nice. Let's go. So that was good. Once I split it up into the function, it made it a lot easier to see. All right, cool. So that was the first one. Let's do. This time. Greatest common divisor of strings. For two strings s and t, we say t divides s if and only if s is equal to t plus t plus t. T is concatenated with itself one or more times. Given two strings, string 1 and string 2, return the largest string x such that x divides both string 1 and string 2. So string 1 is ABC, ABC. String 2 is ABC. Output's ABC. String 1 is AB, AB. Okay. Leetcode. There's nothing. So it's like... We say t divides s if and only if s is equal to t plus t. Okay. So there just has to be... What if it's like ABC 1, 2, 3 ABC? The output would be ABC 1, 2, 3. Let's try that. Okay, well, let's see. X, Y, Z. X, Y, Z. Wow, so it has to be, it can't be anything extra. So it only divides if Leetcode silence. Nobody has been streaming? What's up, smart coder? All right. So yeah, I can't have any other strings in there other than string 2. And so yeah, I just have to check if string 2 Okay, I think I can do this. So what I think I can do is that not a right thing to do? I'm supposed to have your name in my tag, right? Bullying. And so Okay, so I think what I can do maybe is take the length of string 2 and divide the length of string 1 and multiply that by string 2. And if they're even, oh no, so wait a second. Not if they're even. Yeah, so multiply it, and if they're even, then I return just the division of the length. That could be an easy way to do it, right? So like I do the length of string 1 divided by the length of string 2. So in this example, it would give me 6 divided by 3. So that would equal 2. And if that, I may be doing an extra step here. If this times string 2 is equal to string 1, then return string 2. Is it like, no, never mind, I don't know. This would be one. No. I'm doing this wrong. So what happens if it's ABC, ABC, ABC? Let's try that. I need more information. ABC, ABC, ABC. So it's still just string 1. How is that? How does that work? This one, oh, because it just removes, I don't know. Wouldn't this be just this and removes this? That is confusing. How about just one? Okay, I'll look at the definition. So it says T divides S if and only if S is equal to T plus T plus T plus T. T is concatenated with itself one or more times. So T divides S. Return the largest string X such that X divides both string 1 and string 2. Oh, it has to divide both of them. Okay, yeah, I was reading it wrong. The largest string that divides both of them, okay. So that would be... largest string that divides. What confuses me though is if we have ABC, XYZ, and ABC, do we have ABC as the result? If we don't, AB doesn't divide AB. Oh, yeah, okay, I see. It's AB, that's what I'm doing. Oh. It's AB that divides both. Okay, so okay, so I probably want to take the minimum string and so I'm gonna build a string that divides both of them. So maybe I can do what I was thinking and start with like one, but start with each character of So for this to work, there has to be a repeated pattern. So we can start with, okay, maybe start with the beginning. Okay, so I just have to start at the beginning, and whenever they don't whenever it differs, then that's the answer. However, I take that and I have to compare that multiplied by, yeah, so let's do this. So so I think to find the string that I need, I just have to compare both until they differ. And then that's the string that I could possibly use. But then I have to maybe then I have to take the max length of this two strings and divide that by the length of the string that I have and multiply that by the output, and if that's equal to the max string, then I can output that value, or else I output nothing. All right, let's do the first part. So for I in range, so let's see. Maybe we do range length min. And we do if I two I equal. Let's do this. All right, so this should give us the string that potentially could be legitimate, or potentially could be the output. But then I have to check if there's no like XYZ at the end of the string 1 or something that disrupts these t plus t plus t. And to do that, look at example 2. Example 2, AB's the output, and what's significant about this? Maybe string 1 is 3 ABs and string 2 is 2 ABs. You'll add AB to res, but the answer is AB. Oh yeah, so my idea is not working. I'll add AB to res with my. The answer is AB. Okay, so I can't do this. So what can I do? Read comment about the length. So the length of the string. So the length of the first string in example 2 is 6, and example for the string 1 is 6, string 2 is 4, and the output has a length of 2. So would that mean, okay, so let's say string 1 was AB, 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 then the output would be AB, AB, AB. But now what if it was, if T divides S, what can you say about their length? If T divides S, then S is a multiple of T. Their length is a multiple the length of T. Length of T divides the length of S. Length of T divides the length of S. So the output is t, and these are the s's. So the length of t divides the length of s. So both. Oh, so maybe we find a number that is divisible by both. That divides into both. We find a number that divides it into both. And then yeah, we find a number that divides into both. So this would be 6, this would be 4, and 2 divides into both. 6 and 3, 3 divides into both. Oh, great, yeah, greatest common divisor. That's the problem. But then how do you deal with this scenario, I guess? If you're just focusing on the lengths. Or a scenario where largest string. So I have to find the GCD of both lengths. And then what? Maybe divide it by that GCD. GCD of both lengths. How do you... Okay, so what does this do again? Okay. So I could just use it like that. Okay. GCD not defined. Thought I could use anything. Garcia, hello. Thank you for the follow. I thought I could just use this. I can't use that. I guess I can't use it. So I'm stuck. I don't know what to do here. Given two strings. GCD should work. Oh, maybe that. GCD. Okay, so once I have the GCD, then that should give me the length of the string output. Then what? Then how? You know the only possible length of the answer. So the only possible length of the answer is, yeah, that GCD. So maybe I take that number and multiply by, okay, so maybe I go like this. And then I say if you have a string of s of length 9 and you want to divide into a string of length 3, what can you do? You have a string of length 9 and you want to divide into a string of length 3, what can you do? Divide into. Divide it into strings of length 3? C plus C plus C plus C. Okay. So loop through the string. How can you check if it's possible and what would it be? Maybe every x indices, checking if the x amount of letters is equal to the first x amount of letters. S3 times 3 is equal to that. So that would be S is equal to so S X times X. S times X is equal to string string 1. Would it be length of the thing? Yeah. Yeah, that's what I was thinking. So it should be the length of the string. Mod. String 1. So if the string up to the greatest common denominator length times the division of the length string, but this would be S would be S string 1 and string 2, and this would be either one. And so if this would be, in the first case, it would be 6 divided by 3, which is 2 times 3. Should be that. Or 2 times that string. And then this would be 1 times that string. In this one, it would be 6 divided by 2 is 3 times the string. 4 divided by 2 is 2 times the string. It has to be both, right? Yeah, both. So in this one, we have expected this and we return this. How is that possible? There is no S. For ABC and XYZ, you'll return ABC. Will I? It seemed to work here. But for this one, it didn't work. I guess because it's the same as example 3. Example 3 isn't a special case. You're using string 2 in the second term of, you should use the answer in both cases. Oh, the answer in both cases. But no, this one's string 2. Yeah. Okay. All right, so I had to, get the understanding that I'm finding the GCD. And then I kind of was thinking to do this, but I just didn't get the concept of the GCD. But I was thinking to multiply the string, and then also using the GCD to create the string too. That's good. All right. Let's go to the next one. Count complete subarrays in an array. You're given an array nums consisting of positive integers. We call a subarray of an array complete if the following condition is satisfied. The number of distinct elements in the subarray is equal to the number of distinct elements in the whole array. Return the number of complete subarrays. A subarray is a contiguous, non-empty part of an array. Okay. 1 3 1 2 1 3 1 2 2 3 1 2 and 3 1 2 2. Number of distinct elements in the subarray is equal to the number of distinct elements in the whole array. Oh, okay. And subarray is contiguous, non-empty. So what is the, okay, it's 1000 is the length of the nums, and yeah, 1000 is the length of the nums. So so I gotta create the subarrays, and then I have to check if the sets are intersecting. I think that's the idea. Hey, Patrick, thank you for the follow. So I create the subarrays. So I can do that. Okay, so I think I go for I in range. I think I create the subarrays like this. But maybe it's not empty, so maybe I start J at 1. Like that. And a subarray could be nums I J. And we can have a set of nums. And then we can check if the, what am I doing? We can check if the set intersects with num set. And how do we do that again? Intersection sets Python. Intersection. Or do we? If you slice, your code will be cubic. Yes, because I'm slicing. I can't. Yeah. Why do you need the intersection? You can just check the number of elements. Okay. So I don't need intersection. You just need to check the distinct elements. It's just, yeah, checking the number. That's all I'm doing. But I can't intersect. So how do I get around that? I can't slice. So what am I doing? Maybe every I I can just reset the set and check the count. Maybe. So like Hello, Vidori. Thank you for the follow. Okay, so I'm looping through and adding to the set. Until I get to the end. So I can start from 0 then, right? If I start from 1, do I start from I? And then I go this. Go. So we add to the set 1 complete subarray. This is 4 complete subarray. This one. This one. This. Ah, okay. Yeah. So add to the set and then check if the lengths are equal, and if that's equal, then you add 1 to the output. If length x set So I'm only adding to the output if all the numbers, or if the sets have equal distinct numbers, equal length. Maybe that's it. So I should be, oh no, I'm adding J. Meant to add, or I'm adding I, meant to add J. So let's just try another case. So that should be good. Submit. All right. Okay. That's good. Minimum operations to exceed. Oh, they make it linear. Let me see real quick. How did I make? Wait, what? Yeah. Okay. We'll do that in class. Probably something we've seen before, and I just can't remember. Minimum operations to exceed threshold value 2. You're given a zero indexed integer. Oh, it's a new technique. Nice. I like new techniques. Oh, there was one question that I did, and we can go over it in class, but it had to do with, I think, shifting. I think maybe I didn't need to shift, but that was what I was going to ask you. But it was definitely using bits. And so, yeah, but you just taught me that, how to shift. So it's pretty cool if that question also needed to shift, and now I can use it. But yeah. You're given a zero index integer array nums and an integer k. In one operation, you will take the two smallest number or integers, x and y, and nums. Remove x and y from nums. Add min xy times 2 plus max xy anywhere in the array. Then you can only apply the described operation if nums contains at least 2 elements. Return the minimum number of operations needed so that all elements of the array are greater than or equal to k. 2 times 10 to the 5. Number is 10 to the 9. K is 10 to the 9. Input is generated such that an answer already exists. That is, there exists some sequence of operations after all elements of the array are greater than or equal to 2, or equal to k. There exists some sequence of operations after which all elements of the array are greater than or equal to k. So there exists some sequence, but we need to find the minimum number of operations. So we have this integer. We take the two smallest integers, x and y, and nums. So 1 and 2. Remove them. And then add the minimum of the 2 times 2 and the max to the maximum anywhere in the array. and then you return when all of them are greater than or equal to k. Huh. And there's num's length is 2 times 10 to the 5. So maybe we first sort the array with, or sort it in descending order. The biggest to smallest. And then you can only apply the described operation if nums contains at least 2 elements. So what happens if it's like 11, 10, 10, 13, and 1? Oh, wait. Yeah, you could do that. Okay, so if there was 1 that was still less than 10, okay, so yeah, sort it from biggest to smallest. Check the, or pop the smallest number. And if it is less than 10 or less than k, then we pop another number and we do the operation. Maybe we have to use a heap, because then we're putting it back into the sorted array. And then we just do that. We keep doing that and count the number of operations. Okay, I think that's it. So heap q, or so heap is just we gotta create dot heap q dot heap. I don't remember. Nums? Is that it? Return 0. Let's try. Heap q dot I don't remember. Heap the font, or it's 1p. Does it just does it look like it's sorted? Or am I messing this up? Or I need to do that. It doesn't, yeah, but so it doesn't sort. It doesn't sort, but doesn't it like let me look at this. It makes it so that you pop the smallest number, right? Let's do noms dot heap or heap q heap noms. Okay. So yeah. So we have the heap and we pop the last one. So maybe I gotta do while we do x is equal to this while x is less than 10, or sorry, less than k. So while the popped number is less than k, we're going to, if we're entering the loop, we pop another number, y is equal to heap q dot heap pop noms, and then heap q dot heap push the minimum of x and y times 2 plus the maximum of x and y. So this would take that value, push it into the heap, so that way it organizes it. And if it's the minimum, it'll put it at the end. And then we keep checking until the minimum is greater than or equal to k. But each time we do this, we're gonna add to the counts the result. Or we can do, no, yeah, just add to it. And then we return the result. Expected one argument. Invalid syntax. What am I doing? It's the value and then nums. Is it? No. Nums and the value. Keep. The heap and then the item. Let's try that. I need to at the end of it pop x. So I need to set x again. X is equal to this. Okay. Alright, I think this should be good. Alright. Nice. Okay, number of ways to buy pens and pencils. You're given an integer total indicating the amount of money you have. You're also given two integers, cost 1 and 2, indicating the price of a pen and pencil respectively. You can spend part or all of your money to buy multiple quantities of each kind of writing utensil. Return the number of distinct ways you can buy some number of pencils. Total is 20, cost 1 is 10, cost 2 is 5. Let me look back at that one. So instead of doing this, instead of repeating the code that assigns x, you can do num0 in the while condition. Num0. Num0. That just that one? Index out of range. Well, don't I have to assign x at the end either way because of this formula here? Or does x equal to y? Or no, x is equal to, yeah, I don't know. Only when you assign to y. You still have duplicated x assignment. So x, you get x, you pop it, you get the y, you do the calculation to get the new number. And now you have y there. And x still. But when you loop around, you're just getting the lowest number. So instead of, do I just do num0 here too? No. Assign x before assigning y. Okay. And remove line 9. Got it. Okay. All right, this is going to be my last one. You're given an integer total indicating the number of amount of money you have. Okay, so 20 is the total, cost 1 is 10, cost 2 is 5, output is 9. Number of distinct ways you can buy, number of pens and pencils. 0 pens, you can buy 0, 1, 2, 3, or 4 pencils. 1 pen, 0, 1, 2, or 2 pencils. If you buy 2 pens, you cannot buy any pencils. So 5 times 3, or 5 plus 3 plus 1. Okay. Hmm. You can buy 0, 1, 2, 3, or 4 pencils. You can spend part or all of the money. So you can buy 0 pens and 0 pencils, and that counts as 1. 10 to the 6. For total cost 1 and cost 2. So yeah, this one is 0 pens and 0 pencils. Counts as 1. So minimum output is 1. So maybe it's the division of total minus the cost, or total divided by the cost is plus 1 is the output. So basically, and the cost 1 is 10. So I can do when cost 1 is 0, cost 1 is 10. So let's say total was 40. 40 divided by 10 is 4. And so I would do 0, 1, 2, 3, 4. And then I would do the cost 2. So maybe I maybe I divide cost 1 by the total. And if it's not 0, we go from 0 to that total. 0 to that number. And then what can I say about the constraints? I can say that hmm, I can say that my solution can't be quadratic. It has to be, not quadratic. Um, yeah. And so if I what can it be? Um, it can be. Can it be n log n or n? Well, it could be O of n. I don't know if it could be n log n. I guess log n.
What would an ON solution look like? An ON solution would maybe be you go from 0 to whatever multiple of 10 is the most you can get from the total by division. You find that number and you loop through that number from 0 to that number. And each pen um, pen, you take that number you're at. So if you're at 0 pens, you multiply that by the cost of the pen and you subtract it by the total, or you subtract it from the total, and then you divide the cost 2, and that's how much pencils plus 1. So in the first example, you would have, for the second, for 1 pen, you would have only 10. 10 divided by 5 would be 2 plus 1. Yeah, 0. Yeah, so I think it would look like this. I think it would look like and res plus res equals 0. Res plus or equal to 1 times x. So I wanted to, yeah, plus 1 times x total minus cost 1 times x divided by cost 2. Maybe that's a way to do it. No. Output is 6. So what I was expecting was on 0, we would have 20 minus 0 times 10. And 20 divided by 5 would be, 4 plus 1. So this would be 1. Wait, is this like, why is it only showing 2010, 2010, 10, 10? All right. Thanks for the help, Lee Coach. I'm about to go too after this question. Good night. Thank you. I think that's good. Nice. Okay. We solved it. We just did 5 questions. Wow. So this week I completed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 questions I completed this week so far. And I still have tomorrow and Saturday. All right, guys. Thank you for watching me. And I'll try to come back tomorrow and do some more. Thank you. Goodbye.